Hello students, in this second lecture of chapter continuity, we will discuss some more examples related to this concept. Let us start with example number 20 from the book NCERT. Is the function defined by f of x equal to x square minus sin x plus 5 continuous at x equal to pi? This is our question. Now, how can you check the function is continuous at any point or not? You know that the definition of continuity, which is a given function is continuous at a point if the value of function at that point is equal to the value of the limit at that point. So, f is continuous if f of pi equal to limit x tending to pi f of x. This means left hand limit and right hand limit are same, only then the limit of a function exists. So we need to check f of pi equal to limit x tending to pi negative, f of x equal to right hand limit. Now come on to the value of f of pi, which is pi square minus sin pi plus 5 equal to pi square minus 0 plus 5 equal to pi square plus 5. Now left hand limit. Limit x tending to pi negative x square minus sin x plus 5. Here there is no denominator, so we can easily find the left hand limit by direct putting the value of x equal to pi. So it will be pi square minus sin pi plus 5, pi square minus 0 plus 5 equal to pi square plus 5. You can also use the other method, which is put x equal to pi minus h, and as x tending to pi, h will approach to 0. So we are left with limit h tending to 0, pi minus h the square minus sin pi minus h plus 5. Now put the value of h as 0, you will get pi square minus sin pi plus 5, which is again same, that is pi square minus 0 plus 5 equal to pi square plus 5. So you can easily check the right hand limit. I will leave this part for you as an exercise. So you will check that the right hand limit will also comes out to be pi square plus 5. All the three values are same, so you can say that the function is continuous at x equal to pi. Right? This is one method to solve this question. There is one other method, second method. Using the properties of continuity. You can say that if f is f1 plus f2, if the function is divided into sum of two functions and both f1 and f2 are continuous, then its addition is also continuous. This will implies f continuous, right? Similar for the case of subtraction, for the case of multiplication, and for the case of division. But for division, you must check that f2 should not be equal to 0 because denominator should not be equal to 0. So in this case we can say this is our f1, this is our f2, this is our f3. So we express our function f as the sum of f1 plus f2 plus f3, and here you can say since f1 is continuous. Why f1 is continuous? Because x square is a polynomial and every polynomial function is continuous everywhere. f1 is continuous. Why f2 is continuous? Because sine function as cos function, you know that these functions are continuous because their graph looks like this. This is a continuous curve. So f2 is also continuous at all points, so it is continuous at x equal to pi as well, right? Then 5. What is the graph for 5? Y the value 0, 1, 2, 3, 4, 5. It will be like this. This is also continuous. 5 is a constant value, constant function is also continuous. Or you can say 5 is a polynomial of degree 0, so every polynomial is continuous, so 5 is also continuous. We have shown that f1, f2 and f3, are continuous everywhere. So it is continuous at x equal to pi as well. So their sum will also be continuous. This implies f is continuous at x equal to pi as well. Clear? Now try some other question. You can easily try question number 21. I'll discuss this question. Discuss the continuity of the function. First question is f of x equal to sin x plus cos x. You can also use this method f1 plus f2. In the b part it is sin x minus cos x. You can also use the same property in subtraction case. And the third part is sin x multiply cos x. Here you can also apply this property as well. So I leave this question for you as an homework. Now question number 22, you can leave this question because this question is not important for Punjab School Education Board purpose. So you can leave question number 22. 22 number question, you can cut this question. You need not to solve this question. Next question is 23rd question. F of x is defined as sin x over x when x is negative, x plus 1 when x is greater than equal to 0. The question is find all points of discontinuity of f where f is defined as this. Now you need to find all the points of discontinuity. First, the function is defined as when the value of x is less than 0, the function takes the value sin x over x, and when x is 0, the function takes the value x plus 1, and when x is greater than 0, it will take the value x plus 1 as well. So you need to check the point value and the limit, left hand limit as well as right hand limit at x equal to 0 only, right? Because x plus 1 is polynomial, it is continuous, so it will be continuous at all points x greater than 0. Sin x over x, sin x is continuous function, x is continuous function, x is not equal to 0 here, so their division must also be continuous using the properties of continuity. So you can say that this function is continuous, this function is continuous. So the only point where the function may not be continuous is at x equal to 0, right? Now first find the value of f at 0, which is 0 plus 1 equal to 1. Left hand limit, limit x tending to 0 negative f of x, limit x tending to 0 negative sin x over x. You can put x equal to 0 minus h. As x tending to 0, h will approach to 0. So limit h approaches to 0, sin of 0 minus h over 0 minus h, which is limit x tending to 0, sin of minus h over minus h. Sin of minus theta is minus sin theta over minus h. Minus minus cancel and sin h over h when limit h tending to 0 is 1. You have done this in plus 1 class, right? Now the function value is 1, left hand limit is 1. You need to find the right hand limit. It will be limit x tending to 0 plus f of x, limit x tending to 0 plus sin x over x. Put x equal to 0 plus h, which is same as x, because as x approaches to 0, h will also approach to 0. Limit h tending to 0, the function will be this is not the function. The function will be when x positive 0 positive, function is x plus 1. So it will be 0 plus h plus 1. Put h equal to 0, 0 plus 1 equal to 1. The right hand limit is also 1. 1, 1, 1, all are equal. So the given function has no point of discontinuity. This function is continuous everywhere. or you can say there is no point where the function is discontinuous. Thank you.